Hey everybody, this is Larry. This is day 26 of the Leetcode December Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think. Today I'm again doing it on my bed because in this rustic mountain spot, there's no table, so this is the best I can do. Today's problem is, 973, K closest point to origin. Before we get into that, there's no drone video today. I'm really tired, so we'll see how that goes. But I don't know. Maybe I'll incorporate that more a little bit. Let me know in the comments what you think. But also just join me on Discord. Okay. Anyway, let's see. What is the dimension or distance metrics? So this is D2 or linear distance. You just return K closest points, right? Okay, I mean, so the straightforward thing to do, of course, is just to something just fell. Just do a sort, right? You sort out all the numbers and then just return the first K. What is the complexity of that, right? Well, the complexity of that is going to be n log n because you're sorting n sets of numbers. You can actually do better than that by using a heap, right? Using a heap, you only have to keep track of the K, like this is literally a top K problem, and top K problems in this case, you could use a heap of size K, which means that for every operation, you're doing it log K instead of log N. And in that sense, it's going to be N log K as a result. So yeah, so I think that's going to be good enough for me. Yeah, I think that's good enough. So yeah, I don't think there's any. I'm just checking to see if there are any weird constraints that would make it, like maybe there's a easier way to do it or something silly like I don't know, x and y is like less than 10 or something. Maybe in that case, then you yeah, maybe in that case you do something other funky things. But yeah, anyone do admin of code by the way? If so, let me know in the comments below how you finish. I was just curious. This is my first year where I've placed on the leaderboard, so I'm happy about that. Just to also give that update. All right, maybe we'll chat about that a little bit more. But this one, I think, like we said, let's just do it then. Right? We have the heap. We have yeah. Okay. So yeah. So for x, y, and points, let's see. Yeah. So we want to push. I always have to take a second to remember what the syntax is in Python because it's a little bit awkward, even though it is a min heap instead of a max heap, so which is easier for this problem. But yeah, I always put things into a tuple. The reason why I put things in a tuple is because the ordering in Python anyway is per element, and so that's the way that I break it down. So yeah, so then you have xy, of course, and the distance, which is, technically is the square root of this. I don't know if this is fast or not. But yeah, technically it's the square root of this, but if you square every number, that doesn't, that doesn't change the ordering. And square root in general are more expensive, but depending on how familiar you are with it, because you definitely do not want to prematurely optimize. You just want to regularly optimize. But for me, I'm confident because I've done this like too many times. Yeah, and then now, oh, actually, I was wrong here, right? So I said we want min heap because we want the first K, but we actually want max heap. That way, the top element is something. I always mix this up until I like actually implement it, which is whoops. Sorry, friends. Hopefully that didn't confuse you. But you want a max heap, and the reason why you want a max heap is because you want to remove the biggest element every time, basically, right? So that everything else in it is the min. So that's basically the idea. So here, to make a min heap into a max heap, at least in Python, there are different ways you could do it. The way that I do it is I just times it by -1. So then now min is max and max is min, right? So yeah, okay. And of course, to keep it log k, we have to make sure that the size of the heap is k, right? So if this is true, then we remove the biggest element. So yeah. And then at the very end, in theory, you're supposed to pop this n times or whatever it is, or k times, I guess, to get the list, to get it in the good order or whatever. But because you can return the ends in any order, it doesn't really matter. So you could actually just return the heap itself, because this heap is actually in a way. Oh, excuse me. So I think that's all I'm gonna have. This is, like I said, ooh, yikes. Oh yeah, whoops. Okay. I was wrong about that because I kept the distance. That's basically the reason. So yeah, so I can just do something like, something like that should be fine. But that's why you run and that's why you test things, right? This looks good. Let me see if I handle the 0 case enough. No, there's at least 1 point. So okay. So let's give it a submit. Kind of wrong answer that one time. But today we got the right answer. Yay. 635 streak. Cool. I think that's all I have, really. Let's see. What did I do here? Okay, this one I did the same thing. That's a little bit more awkward, I guess. How did I get it right the first time and then change it? Oh, yeah, of course, this is like what you said, right? We just have to sort it, but of course, that's going to be more expensive. All right, that's all I have for today. Let me know what you think. Hopefully tomorrow I'll have a test again. I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.